61% of a town's residents own a dog and 70% own a cat. And we also have, of the dog owners, 49% also own a cat. Let's write down the probability notation for that. So we have the probability of owning a dog is given as 61%, which is 0.61. Then we have the probability of owning a cat is 0.70. And then if we look at just the dog owners, 49% of those own a cat. So the probability of owning a cat, given that they already own a dog, is 49% or 0.49. So these are our probabilities given to us, and we just wrote down the appropriate notation for this. In part A, it says, what's the probability of owning a dog? And that was given to us. That's 0.61. The probability of owning a cat was also given to us. That's 0.70. And then the probability of owning a cat and a dog, that we have to do a little bit of work for. So just in general, remember, I'll make the notation down here. If we have the probability of two events, A and B, we can write it one of two ways. We can write it as the probability of A times the probability of B given that A has happened, or we can write it where we switch the events. We have the probability of B times the probability of A given B. So since we have the probability of owning a cat given that they already own a dog, I'm going to rewrite this and statement as the probability of owning a dog times the probability of owning a cat given that we have a dog. So I need to take the probability of owning a dog, which we know is 0.61, and multiply it by the probability of owning a cat, given that we know they already own a dog, so that's 0.49. When we multiply that together, we get 0.2989. Now, in part D, it says we want to find the probability of owning a dog, given that they own a cat. Well, we have the reverse of that, where the events are switched. And we have the probability of owning a cat and a dog. We just found that in part C. So I'm going to rewrite this. I have the probability of owning a cat and a dog, and that's going to be equal to the probability of owning a cat times the probability of owning a dog when we know they own a cat. This is what we're looking for. I'll highlight it. That's what we're looking for. And we have this other information here and here. So I'm just going to solve this like I would in any other algebraic equation. So I have the probability of having a cat and dog. That was what we found in part C. So that's 0.2989. And that's equal to the probability of having a cat, which is 0.70, times what we're looking for, which is the probability of owning a dog, given that they already own a cat. So now to solve this, I just have to divide both sides of the equation by 0.70. And I'll have that. The probability of owning a dog when you already own a cat is, and then that, when I take 0.2989 divided by 0.70, that gives me 0.427.